Day 835 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem. We're doing daily LeetCode problems. And today we have question number 2029 Stone Game 9. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. Alice and Bob continue their games with stones. There's a row of n stones and each stone has an associated value. You are given an integer array of stones where stones of I is the value of the ith stone. Alice and Bob take turns with Alice starting first. On each turn, the player may remove any stone from stones. The player who removes a stone loses if the sum of the values of all removed stones is divisible by 3. Bob will win automatically if there are no remaining stones, even if it's Alice's turn. Assuming both players play optimally, return true if Alice wins and false if Bob wins. All right, y'all, so that may seem a little bit confusing at first, but let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So, in example 1, we have our input stones equals an array of integers 2, 1. The output is true. The explanation says the game will be played as follows. Turn 1, Alice can remove either stone. Turn 2, Bob removes the remaining stone. The sum of the removed stones is 1 plus 2 equals 3 and is divisible by 3. Therefore, Bob loses and Alice wins the game. So, no matter, just to break this down one step further, Alice can remove any one of these stones, right? No matter what stone Alice removes, sorry, y'all. No matter what stone Alice removes, Bob is going to have to remove the stone that, where the sum is divisible by 3. And it says right here, the player who removes the stone loses if the sum of the values of all removed stones is divisible by 3. So once Bob removes his stone, whichever stone it is, once he removes it, then all of the removed stones will be divisible by 3 because it'll be 1 plus 2 plus 3 no matter what order it is. And since Bob will be the one who removes that stone, he'll be the one who loses. So just in case that didn't make sense, let's take a look at example 2. So in example 2, the input stones equals an array of integers 2. This time the output is false. Explanation says Alice will remove the only stone and the sum of the values on the removed stone is 2. Since all of the stones are removed and the sum of the values is not divisible by 3, Bob wins the game. So in this case, Alice is going to remove the only stone. And since it says right here, Bob will win automatically if there are no remaining stones, even if it's Alice's turn. So since Alice went first and removed all of the stones and they're not divisible by 3, then Bob wins the game. Boom. Now, just in case that didn't make sense, let's take a look at example 3. So in example 3, we have our input stones equals an array of integers 5, 1, 2, 4, 3. The output is false. Explanation says Bob will always win. One possible way for Bob to win is shown below. First, turn 1, Alice can remove. Let's just do this. Let me copy and paste this, y'all, so we can go through it. So then it says Alice can remove the second stone with the value of 1, sum of stones 1. So let me put this sum right here. Sum equals. Boom. So Alice is going to remove that. Boom. Right now the sum is 1. Then now it's Bob's turn. Bob removes the fifth stone with a value of 3. Sum of stones removed is 1 plus 3 plus 4. Equals 4. Sorry. So we're going to remove this 3. Now remember, the goal right now is for them to not remove a stone where the sum would equal to 3, because then they'll lose. Like if Bob would have chose to remove this 2, then the sum would be equal to, sorry, not equal to 3, but the sum would be divisible by 3, and then Bob would lose. But instead, Bob picked this 3. Boom. So now the sum is equal to 4. And it's Alice's turn. So Alice removes the fourth stone with a value of 4. Sum of removed stones is 1 plus 3 plus 4. Sorry. Boom. So we'll just take that, remove that. Let's see, boom, plus 4. Now the sum is 8. It's still not divisible by 3. And it's Bob's turn. He removes the third stone with a value of 2. Sum of removed stones is 1 plus 3 plus 4 plus 2. So Bob removes this 2. Come over here. Plus 2. Boom. Then it says turn 5. Alice removes the first stone with a value of 5. Boom. Now the sum is 15. When we add all 1 plus 3 plus 4 plus 2 plus 5 equals 15. Alice loses the game because the sum of the removed stones is 15, is divisible by 3. Bob wins the game, y'all. So, boom. So, once again, that was the last stone, and that was the stone that made it divisible by 3. So, Alice loses, and we return false because Alice lost. So, boom, y'all. I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. The solution is not that difficult at all. Now we need to count how many stones have each possible remainder when divided by 3. So we're going to declare 3 variables, count 0, count 1, and count 2. And it's going to be, so the first variable will be count 0, and we'll set that equal to 0. And that's going to be stones with that are divisible by 3. Boom. Or a value, sorry, that's going to be a value that's divisible by 3. Then we're going to declare another variable called count 1, and we're going to set that equal to 0. And that's going to be mod 1. So count 1 is going to be a value that has a remainder of 1. And then we'll do count 2, which will be a value that has a remainder of 2. Boom. Now we're going to classify every stone based on its remainder modulo 3. So we're going to come right here, declare a variable called for_val stones, in stones. We're going to open up the brackets and we're going to say let t equal val mod 3. Boom. Now we're going to do a switch statement. So switch t, open up the brackets. We're going to do case 0, stones divisible by 3. So we're going to do count 0 plus equals 1. Then we'll come underneath that. We're going to say case 1, and we're going to say count 1 plus equals 1. Then we'll do case 2. Sorry, y'all. Should be a space right here. Case 2, stones with, which are the stones with the remainder of 2. Once again, these are the stones with the remainder of 1. These are the stones that are just divisible by 3. Case 2 is going to be count 2 plus equals 1. Boom. Then we'll come underneath that and we're going to say default : this case is never reached because the remainder when dividing by 3 can only be 0, 1, or 2. So we'll say default : break. Boom. And if there's an even number of remainder 0 stones, they do not affect whose turn it is in the final analysis. In this case, Alice can win only if there's at least one remainder or one stone, remainder 1 stone, and at least one remainder 2 stone available to start the game. So we'll come right here and we'll say if count 0 mod 2 equals 0, we're going to open up the brackets and we'll say return count 1 is greater than or equal to 1, and 2 and signs count 2 is greater than or equal to 1 as well. Boom. And now otherwise there are an odd number of remainder 0 stones, so they effectively flip the advantage between the players. Alice can win only if one remainder group outnumbers the other by more than 2. So we're going to come underneath this and we're going to say return ABS, open up the parentheses, count 1 minus count 2. Boom. Then we'll come outside of that is greater than 2. Boom, y'all. That's all she wrote. Let's give it a run. Make sure it run. Okay, let's see. Oh, this should be count 0. So let's fix that. Run it again. Let's see. It's accepted, so let's go ahead and submit it. And look at that, y'all. 9 milliseconds beats 50% of users. That's what I'm talking about. That's what I like to see, y'all. So before we go, make sure you get one more look at the code. This is the top part. This is the bottom part. And yeah, y'all, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.